Welcome to Activity 2.3.2, Project Lead the Way's Parametric Constraints. My name is Mr. Gleason and I will be helping you with this task. In this lesson we will be building a part that has a slot and a hole using parametric constraints. First, we're going to start out with a standard IPT. Alright, there it is. We need a rectangle. Grab onto our rectangle tool from the origin, drop it in. Doesn't matter how big it is because we will dimension it using parametric constraints. Right click, done. Next step, let's dimension. The first thing we're going to dimension, we are going to dimension the overall plate depth. Looking at page 4, our overall plate depth, D0, is 3 inches. Drop it in. Center this out a little bit. Right. And now we need to measure and dimension our overall plate width. We don't want it to be 1.255. We want it to be some sort of equation. And that's what our geometric relationship is. It's telling us that it's a ratio of 5 to 3 of the overall plate width to the overall plate depth. So, our equation is going to look something like this. D0 times 5 divided by 3. End parenthesis, and there we go. Now, looking at what we have here, we have something that says fx of 5. Fx stands for function of x, telling us that it is a equation. Perfect, right on. Right click, done. And we need to leave the 2D world and enter the 3D world and finish our sketch. Let's make this thing look better. Let's extrude it. We need to select our profile and our distance, which is going to be our plate thickness, D2. D2, for geometric relationship, says that it is 20 times smaller than the overall plate width. Now we're going to find out what overall plate width was. We just did it. It was D1. So we're going to type in D1. And it's 20 times smaller than D1, so we're just going to divide it by 20. We're going to drop that in. Now we don't want to commit to anything yet. There's a feature, a tab here, the More tab. We need to click on this. Under this More tab, it tells us about taper angle. Oh, look at that, D3. Our plate taper angle is perpendicular to the top and the bottom of the plate surfaces. And it's telling us it has a value of 0 degrees. And that's what we have in there. So everything's all set. We need to commit to it. Okay, let's see what we got. We have an isometric plate. Now we need to go back into that 2D world again. We need to drop in our sketch plane. Now you also want to remember, we never want to draw in isometric. So I'm just going to rotate around a little bit. So we got our plate. Now we need to make the slot. The slot. There's many ways to do this. My way, I say, is the easiest. But you can do it your way. But if you do it my way, you will definitely have no problems at all. And this will also take you less time. 2 circles. Drop them in. It doesn't matter where they are. But it does matter that we get this dotted line and that they share, or their centers are in line. Done. Now we need to make them all the same size. So we're going to constrain them. We're going to use the equal tool. Constrain, constrain. Got 2 circles that are the same with centers in the same line. Right click, done. Line tool, 2 tangent lines. Drop those in. Bada bing, bada boom. There it is. Right click, done. And my favorite tool of all is the trim tool. I always use the shortcut key, X, for trim. We need to trim out these circles to make it look like a slot. Right click, done. Alright, we got some sort of slot here. Now, next step, we need D4. We need our slot width, which is half the overall plate depth. Okay, so we need our slot width. We need to dimension the width from the center points of these 2 circles. Drop our dimension in. It's telling us it's half the overall plate depth. Plate depth is D0, and it's half of it. We're just going to divide it by 2. There it is, half the overall plate depth. Next one, we're on a D5. Slot width location. 4/5 of the overall plate width. 4/5 of the overall plate width. Now looking at page 3, it kind of tells us where we need this dimension to be. So D5 is going to be from this circle's center point and this circle's center point only. Do not use this one. This one right here. So we need to grab our dimensioning tool and we need to dimension the width. There it is. Alright, and we need to type in some sort of equation. It's telling us it's 4/5 of the overall plate width. Plate width is D1, and we need to multiply it times 4 divided by 5. Perfect. Now, what's great about Inventor? If you want to go and divide 4 by 5 out and type in 0.8, then you can do that, and it works. Alright, so we have a function of x here, function of x here, telling us we do have two equations. Alright, next thing, we need to dimension our D6, which is the slot depth location. Alright, so we need to grab onto what? This center point here, and this line right here. Ooh, wrong one. There it is. And drop in our dimension. Alright, so for D6, slot depth location, it's 1/3 of the overall plate depth. Overall plate depth, D0, and it's 1/3 of it. We're just going to divide it by 3. There we go. Perfect. It just moved a little bit. I was pretty close. Finally, this slot does not look anything like the paper. So we need to make those circles the right diameter. We need to dimension the circles. Now they are both equal. We can dimension this one, or we can dimension this one. It doesn't matter. Okay, but before we commit to anything, if we look at this leader here, it is a radius leader of 0.707. We don't want a radius. So before we commit, we right click and we click on diameter. There we go. That looks more like a diameter. Drop that in. Now, for slot diameter, it's 2 times the plate thickness. Plate thickness being D2. We're going to take our D2 and we're just going to multiply it times 2. Ah, look at that. That looks right on. Looks perfect. Next step. We need to right click and done. It's always good to go through and check to make sure that you have functions of x. Function of x, we have all of these equations, so we did it right. Next step, we need to make this object 3D. Okay, now, there's many ways of finishing your sketch. You could come up here and click the button, but I feel that the fastest way is when you're drawing, just right-clicking, finish sketch. There it is. We need to extrude. Do we want to extrude this out from the surface? No, we want to cut it into the surface. We want to cut it into that plate. So we're going to do an extrusion cut. Alright. Now this slot extruded length is the same as the plate thickness as told on page 4 under geometric relationship. What's the plate thickness? Plate thickness is D2. There we go. D2. Alright. D2. Now we need to go under this menu again. We need to check out that taper. It's telling us that our D9, our slot taper angle, is the same as the plate taper angle of D3. There it is. And hit OK. Ah, look at that. We have our beautiful, perfect slot. Next step. We need to draw our hole. Leaving 3D, going 2D. Drop in our sketch plane, and we're off. We need to just make a circle. Does it matter where the circle goes? Not one bit. Does it matter how big it is? Nope. Right click, done. Alright. So, we need to make our hole with location. D10. We're on D10 right now. And it's telling us that it is 1/4 of the overall plate width. Okay. So looking on page 3, D10, we need to grab our dimensioning tool, dimension the center to the outside, drop our dimension down here, and it's telling us it is our plate width, D1 times 0.25 or quarter. And hit OK. Just move our hole over a little bit. And we need to dimension our D11, which is our hole depth location. It's from the center to the top. There we go. And that is 2/3 of the overall plate depth. We're going to take our plate depth, drop that in, and it's going to be multiplied by 2 divided by 3. 2/3. There it is. Moved a little bit. Finally, we need to change our diameter. Of course, that doesn't look anything like the piece of paper. So we need to make this diameter. We are going to dimension diameter. Oh, look at that. We have our diameter feature already. We don't have to right-click radius. And we got to type in some sort of dimension here, telling us that our hole diameter is the same as the slot diameter. So all we have to do is we look on slot diameter, look up the list, slot diameter, D7. There it is, and hit OK. Just checking everything. We got function of x, function of x, function of x. Perfect. All right, right click done. I always do my right click done and right click finish sketch real quick. And we need to extrude. Now, are we going to extrude this out of the material? No, we want to do our extrusion cut. Finally, we got two more things to do. D13. It's same as the slot height. We look down our sheet. We find our slot height. Where is it? Slot height. D8. There it is. D8. D8. And finally, our taper. We have to go back to that more menu and type in our taper. It's the small hole taper angle. It's the same as the slot taper angle. So all we have to do is D9. Okay, there it is. And we have one perfectly built plate using parametric constraints. Now, how can I tell if you did this right or you just drew it? Well, we have something under our manage menu called our parameters, and we're going to open that up. It brings up a nice little spreadsheet. Really cool. Okay, and it tells us every step that we made here, our D0 all the way through D14. It's telling us the units that it was in, inches and degrees, and it's showing every equation that we inputted into this drawing. It also shows us the values that were calculated just from our D0. So it shows us all of our values that we would put on page 4 of our lab.